Okay, so this is part two of relative humidity notes, and what you're going to do in this one is really figure out how to calculate relative humidity and dew point. It's a really easy thing if you remember a couple steps, and it's important because it helps us to figure out if it's going to rain. If you have a high relative humidity, your chance for rain is going to be higher because there's more moisture in the air. If it's a really low relative humidity day, then you're going to have lots of evaporation and less chance for rain. So that's sort of the reason why we're concerned about relative humidity, um, and we'll get to that part of things in a minute. And if I want to, I just need to move something here. Sorry. Um, Here it is. Okay, so this is on your notes, and if you just take a look at that, you'll see that relative humidity and dew point is important to know the dry bulb and the wet bulb. And again, as I flip back to this, here's that sling psychrometer, and you'll see those in the lab, and I can show you one right now. If you raise your hand, I'll come bring one over to you. But you'll see there's a thermometer without cloth on it and one with it. You're going to get that cloth wet, and you're going to spin it around, spin it over your head. And what that will do is give you two temperatures. One is called the wet bulb temperature, which is the temperature of the thermometer that's wet, and the one that's dry. And the important part about this is the the fact that water will, when it evaporates, cool down whatever it is that it's evaporating from. So if we take the air temperature, which is what the dry bulb temperature would be, and it doesn't matter, just swinging the thermometer around is not going to cool it down. And that's proven by the fact that both of those thermometers are held together as they're swinging. And the air temperature, if you take that wet bulb or dry bulb thermometer and you look at the temperature before you start swinging it, and then you swing it around, it's not going to cool it down. So it's the water evaporating that's actually cooling down the wet bulb temperature, the wet bulb thermometer. And the more water that evaporates, the more it cools down. The bigger the or the more water that can go into the atmosphere or into the air in the room, then there's going to get more. You're going to have more evaporation, which causes the temperature to go down more. So the bigger this difference is between the wet bulb and the dry bulb temperatures, the bigger the temperature difference, or it's also called the wet bulb depression. The bigger that difference, the higher your relative humidity. We use a chart on page 12 in the reference table. Looks like this. We have both dew point and relative humidity. This is the biggest thing that people make mistakes on is you use this chart, but you go to the right page, but if you're asked for relative humidity, sometimes you'll go to the dew point and you'll give a dew point temperature instead of relative humidity percentage. So just be careful of that. Be aware of that there's two charts and know what you're being asked. So the thing about this is it's pretty straightforward. You just have to find the difference between the wet bulb and the dry bulb temperatures. So it's first it says if you have a dry bulb temperature it's 20 degrees, you swing that thing around and you get a wet bulb that's 15. Your dew point temperature and relative humidity they want you to find. So the dry bulb was 20, the wet bulb is 15. Difference, how much is difference between them, is 5 degrees. So then you go to the chart. You know that the dry bulb is 20 and the difference is 5. So if I have the dry bulb temperature of 20 degrees, right here, 20 degrees, and the difference is 5, I follow that down and I follow this over, and we'll get 12 degrees Celsius is the dew point temperature. And if I do the same thing for the relative humidity, 5 degrees is my difference between the wet bulb and the dry bulb. 5 degrees difference. And you go down to 20, which is right here, you would have 58 degrees is the, or sorry, 58% humidity. So it's at 58% humidity, 12 degree for the dew point. So there's your dew point, it's 12, and the difference is the relative humidity is 15 degrees. Okay, so try that for the the next example that's in your notes. Try that for the next example, number 2. It says, find the relative humidity and the dew point temperature when the dry bulb is 14 and the wet bulb is 9. So here's your dew point. Dry bulb is 14, wet bulb is 9. Make sure you get the difference between them and use the dry bulb temperature over here. Find where they meet. That gives you your dew point. And if you go to the relative humidity, do the same thing. Use your difference between the dry and the wet bulb and your temperature here, and that will give you that. Okay. Now, the next thing that I'm going to have you do, okay, so this was from example 1. You'll see that 14 and 9, difference is 5 degrees again, so you just go over 14 degrees, or 14, yeah, down 14 degrees and over to 5, and you should have gotten 4 degrees and 50%. If you didn't get that and you don't understand this chart, raise your hand, I'll come and help you. Okay. See if there's somebody next to you that can show you how to use it. Because